Hello students, today we are going to solve exercise 2.4 of mathematics for standard 9. Before this video we have already completed our 2.3 up to exercise 2.3. So in today's solution class, basically this exercise deals with by using factor theorem and by using remainder theorem how to find that a particular given polynomial of g of x is a factor of another polynomial p of x or not. So question number 1, determine which of the following polynomials has x plus 1 is a factor. So different values of dividend, or we can say p of x is given. We have to check whether the given value of q of x, that is x plus 1, will be a factor of this one or not. So basically here we are going to using remainder theorem. That means we are going to making q of x equals to 0, and after solving this one we will get the value of x, and that particular value of x must be put in place of polynomial p of x, and if the value is coming as 0, then yes, the given polynomial is a factor of this one. So coming to bit 1, it is given that p of x remains constant for all the 4 bits. P of x varies, but q of x remains constant for all the 4 bits. So here q of x is x plus 1. So x plus 1 must be equals to 0. So x is coming as minus 1. So putting this value of x in p of x, we will write p of minus 1, whose value is x cube plus x square plus x plus 1. So cube of minus 1 plus square of minus 1 plus minus 1 plus of 1. So ultimately it is coming as 0. So as 0 is coming, that means the remainder is 0. That means yes, this given value or this particular polynomial is a factor of this one. Coming to second bit, p of x here given as x fourth plus x cube plus x square plus x plus 1. Again same value of x minus 1, because q of x is constant for all the 4 bits. So again this value of x as minus 1 we will put here at p of x. So this value will be this one. But finally after solving this one, we are getting 3 minus of 2, which is equals to 1, which is not equals to 0. So as 0 is not coming, so this x plus 1 will not be a factor of this value of p of x. Coming to bit 3, p of x here x4 plus 3x cube plus 3x square plus x plus of 1. Again by putting x as a minus 1, we are getting a value of 1. 1 means it is not equals to 0. So as it is not equals to 0, so x plus 1 is not a factor of this given polynomial. Coming to bit 4, here p of x is given as x cube minus x square minus x whole into 2 plus root 2 plus of root 2. By putting x as minus 1, we are getting this value, which is ultimately coming as 2 root 2, which is not equals to 0. So as 0 is not coming, so x plus 1 will not be a factor of p of x. Coming to question number 2, it says, use the factor theorem to determine whether g of x is a factor of p of x in each of the following cases. We have given the values of p of x as a polynomial, g of x as another polynomial. We have to check whether this g of x is a factor of p of x or not. Again the same procedure, make g of x equals to 0. Put that value of x in p of x. If 0 is coming, then g of x is a polynomial of a factor of p of x. So here our g of x is equals to x plus 1. So making it equals to 0, x is coming as minus 1. So p of minus 1 will be equals to 0. So as 0 is coming, so g of x is a factor of p of x. Coming to bit 2, p of x given as x cube plus 3x square plus 3x plus 1, where g of x is equals to x plus 2. So x plus 2 must be equals to 0, which means x is equals to minus 2. So putting p of minus 2 or x as minus 2 in p of x, we are getting a value of 13 minus of 14 is equals to minus of 1, which is not equals to 0. Hence g of x is not a factor of p of x. Coming to bit 3, p of x given as x cube minus 4x square plus x plus of 6, where g of x is equals to x minus 3. So x minus 3 is equals to 0. We got x as 3. So now putting x as 3 in p of x, we will get this value which is equals to 0. So x minus 3 is a factor of p of x, or g of x is a factor of p of x. Coming to question number 3, it says find the value of k if x minus 1 is a factor of p of x in each of the following cases. Here the reverse case is given, p of x is given, g of x is given. Condition is given that g of x is always a factor of p of x. That means by making g of x equals to 0 and putting that value of x in p of x, we will always get value of 0. And from that we have to find out the value of k. So here g of x is equals to x minus 1. So it must be equals to 0. That means x is equals to 1. So putting x as 1 in p of x, that means p of 1 will come as 1 square plus of 1 plus of k, and this value must be equals to 0 as g of x is a factor of this one. So 2 plus k is equals to 0, which indicates k is equals to minus 2. Coming to bit 2, p of x is given as this value and g of x as x minus 1. So again x value will come as 1. So putting p of 1 or x as 1 in p of x, we will get a value of k as 2 minus root 2. It's a minus 2 minus of root 2. So we got the value of k. Bit 3, p of x given as kx square minus root 2x plus of 1, where g of x is equals to x minus 1. So again putting x as 1 in p of x, we got a value of k minus root 2 plus of 1, which must be equals to 0. Hence k will come as minus 1 plus of root 2. Coming to bit 4, p of x given as kx square minus of 3x plus of k, and g of x as x minus 1. So x minus 1 is equals to 0, which indicates x as 1. So p of 1 hour will be k whole into square of 1 minus 3 whole into 1 plus of k. So k minus 3 plus of k. This value must be equals to 0. So 2k minus 3 is equals to 0, which indicates k is equals to 3 by 2. So here we are going to stop this video and making it as part 1 for exercise 2.4. Hereafter I will make a part 2, the second part of this particular exercise, which will contain question number 4 and 5. Thank you.